This video is for lesson 5 of the Year 7 light topic entitled Colour. By the end of the lesson you should be able to recall what white light is made up of the 7 colours of the rainbow, describe how white light can be dispersed, recall what happens when colours are combined, and explain how filters work. You may be aware that light is not a single colour but is in fact made up of a mixture of the 7 colours of the rainbow. And we can show this using a so-called prism. A prism is just a shaped piece of glass or plastic through which we shine white light. And when we do that, we find that we get the rainbow of colours coming out at the other end here. And it's in exactly the same way in which rainbows are formed, only instead of having blocks of plastic or glass, it is water droplets which do the splitting of the white light. Okay, looking at this effect in a little bit more detail, if we take our glass or plastic block in the shape of a triangle in this case, and we shine white light in, we find where the white light hits that glass, the light is caused to change direction. And if you remember, we call that effect refraction. Now, because the white light is made up of different colours are refracted by different amounts. We follow it through there. You can see that the red light is refracted or bent the least, and the violet light is refracted or bent the most. And it's because these different colours are bent by different amounts that we get this splitting of white light into the component colours. The overall splitting of white light into the separate colours is what we call dispersion. Okay. Now you need to be aware of those 7 different colours, and you need to be able to name the colours of the rainbow in order. So the best way to do that is to remember something called a mnemonic, where each first letter refers to the colour of the rainbow. So Richard of York gave battle in vain. So R represents red, O represents orange, I for indigo, V for violet, G for green, B for blue, and Y for yellow, and there's our red back at the top there. So that's the order of the colours, and you can remember them using this acronym. You can invent one yourself if you wish, but most people find that that's quite a useful way of remembering it. Okay, so can you put the title dispersion, and this needs to go into your notes. So we need to put the coloured clouds here into the grey clouds here. If you're not sure what goes where to begin with, why not just write out the paragraph and then insert the ones you know, and then think about the ones that you don't. Okay, so pause the video, have a go at it, and we'll go through it in a moment. Okay, so what have we got? We've got that when a white light enters a prism, it is split into a spectrum. Those are the different colours. This effect is known as a dispersion, and if you remember, it's caused by different colours being refracted by different amounts. Red light is at the top, it's refracted the least, whilst violet light is refracted the most. Okay, please check and correct if you didn't manage to get those done. Okay, we're now going to look at how we can combine colours. Now this is different from art, so there's a difference between the way in which colours are combined in art than they are in science, so make sure you learn the difference between the two. Okay, in science we have 3 primary colours: red, green and blue, and where they overlap is where those colours combined. So red and green will produce yellow, red and blue will produce a colour called magenta, blue and green produce a colour called cyan, and the 3 primary colours added together make white again. Okay, so we need to make a formal note of that. Could you put the title Adding Colours? And can you jot this note down? White light can be split up to make separate colours. These colours can be added together again. The primary colours of light in science are red, blue and green. There they are. Blue and red make magenta. Blue and green make cyan. Red and green make yellow. And if you combine the three primary colours, we get white light again. Okay, do your best to combine these. They don't have to be circles, but they do need to overlap in the correct way. Okay, so take your time please and make sure that you get that accurately written down. Okay, lastly today we're going to look at how filters work. Filters are simply pieces of coloured glass or plastic, and what they do is this. If you allow white light to hit a filter, then the filter absorbs all of the colours that are not present in the filter itself. So all 6 colours here will be absorbed with the blue filter, and only blue will be transmitted. Here 6 colours are absorbed except for red, which will be transmitted. And finally 6 colours are absorbed, 1 is transmitted, green. So a filter filters out the colours that are unwanted, if you like, and only allow the colours through that are wanted. Okay, so finally for your notes then, using filters. Filters can be used to absorb some colours and transmit other colours of light. So a red filter will absorb these colours here, but will transmit red. A green filter will absorb 6 of the colours, but transmit green. And similarly with blue, the blue filter transmits blue. Could you make a copy of that please into your notes? Okay, I'm not going to ask you to make this note, but you should be aware of it. We've already seen that a red filter will absorb 6 colours but transmit red light only. That's straightforward enough. But what if we've got a filter which is magenta? Well, if you remember from our colour chart a few moments ago, magenta is actually a mixture of red and blue. So a magenta filter will only transmit the red and blue. Okay, so you should now be able to recall that white light is made up of red, orange, yellow, green, indigo and blue. Describe white light, describe how white light can be split up using a process called dispersion. Recall the names of the 3 primary colours and describe how they can be mixed to produce secondary colours, and explain that a filter works by absorbing some colours and transmitting others.